Going to continue with Java and object-oriented programming with our demonstration of building a class. And then we'll get into more formal object-oriented programming stuff after the demonstration. I just wanted to make sure that you are following along on the Gantt chart. And if you're not, or if you've got some other way of self-organizing, great. But otherwise, we're down to the stretch here. Today is and tomorrow are the last days that you can get help by going to the help sessions or help hours, or by getting help online via the Zoom, right? Okay, we're good. So, hopefully you're 100% done already, and you're just polishing it up. Fixing up the style, fixing up the documentation, maybe a few bugs here and there, but for the most part, it's all working correctly. Getting things into the right package, or you're off by one on one of the figures or something like that. Those are things that, if you have 48 hours, they're very easily to address, right? But if you're starting from scratch, and then you hit those problems, 3 hours before the deadline, they're not going to be addressed. So make sure that you're at that point, and hopefully, maybe you're already at that point, in which case you can say, all right, my weekend, or the rest of my week is clear, and the weekend will be fun or something. Right? All right, so go ahead and get rid of this. Last time, again, we started by creating this demonstration object, this isotope for this class. A class in Java is simply a way that you can model a real-world entity. It's just like a structure in C. If you've got a structure in C, it allows you to encapsulate multiple pieces of data together into one logical unit. Now, in the original example that we did over here, isotope demo, we only had one isotope to deal with. We took some input, we quickly produced some output, and then we were done, right? As long as there was only one need for one isotope per run of this program, great. When we separated these out into 5 different variables, we didn't need a full object. But if we were to say keep track of 50 different isotope samples, right? Now you're talking about 50 times 5 pieces of data, right? Are you going to keep track of 5 arrays of different pieces of data? What if you wanted to sort them, right? It's much easier to deal with them with one logical unit by using a class here. A class also in Java provides even more than a structure in C. A C structure only allows you to encapsulate group data together. But with Java, you can protect that data, and you can group functionality with that data. And that's what we're going to see here today. Continuing from last time, though, remember, we came over here and we needed a way to create an isotope. And so we created this constructor. This constructor takes all 5 of those pieces of data and then assigns them to this object. That way, if I create an isotope of strontium 90, right, with 10 kilograms, I've got one instance here. I can recreate a strontium 90 isotope over here with 5 kilograms. I can create a plutonium 238 isotope over here with 8 kilograms, right? I have different values for each one of these, and they store their own values. We covered the keyword this, how do I represent myself, right? If I'm talking about myself and I'm a human being, I say me, myself, and I. But if you're an object, you need a way to refer to yourself, and that's going to be this, because you're an inanimate object, right? All right, so once we've got this isotope, we can now, this constructor for the isotope, I guess, we can start to use it, right? We came over here and we noted that if we were going to do this over and over and over again, that's a really strong indication that we need to put this into a function. That function turned out to be a constructor, but what's going on now, right? The original constructor, the no argument constructor, no argument as in you didn't provide any parameters here, it suddenly goes away. And that's a Java feature. And it's kind of like a lawyer. If you don't specify a constructor, one will be provided for you. If you can't afford a lawyer, one will be provided for you free of charge. That free of charge constructor here is the no arguments constructor. All it does is initializes all of your values to default values. In the case of numbers, it's going to be 0. In the case of objects, it's going to be null. And 0 here, 0.0, and 0.0 here. Right? So that's why we didn't print it out, but if we had printed out each one of those things, then we would have seen that each one of them is going to be some default value of 0 or null. So now that we've defined our own constructor, now that we can afford our own lawyer, that default lawyer goes away, right? and that default constructor has gone away. So what I need to do now is I need to move all of these things up into the constructor call, because it takes the name of the isotope, the atomic number, the half-life, 28.9, the mass, and the symbol, I forget what it was. So it's atomic number, name, symbol, half-life. Okay, so atomic number is 38, name, symbol was SR, half-life, and then mass. There we go. And now that will compile because we're actually calling that other constructor. Right? There's no problem if you want to retain that default no argument constructor. Let's come over here to the isotope and let's write it. You can have multiple constructors with the same name because all of the constructors have the same name because they're all named after the class. I could have another public constructor here, public isotope, with no arguments, and then an empty body here. If you wanted to, the reason that you would want to do something like this is maybe that you want to define some sensible defaults. For example, this atomic number is equal to -1. By default, if I didn't specify this, then what value would it have? 0. I want this other special flag value of -1 though. Right? Likewise, I don't want null as a default value of name. I'll go ahead and go with this.name is equal to unknown sample. Right? And that can be your default, right? Et cetera, et cetera. If you don't define a default, for example, symbol, then the regular defaults will take over. You can do it explicitly if you really want to. Set that equal to null, but you don't have to. Right? Otherwise, default values take over. Once I've restored this default constructor over here, you can see that in the demo, I can now construct this default, you construct something using that default constructor. There's nothing to stop you from doing this as many times as you want. For example, look, here I'm creating strong TM90 and strong TM90. Let's go ahead and take both of these here. And the first one was 10 kilograms, and the second one was, oops, new, was, what is it, 5 kilograms? 5 kilograms. There we go. And I can get rid of all of this stuff right here. There should be a better way. For example, for the first other constructor that we're going to make here, could I have the idea of a strong TM90 isotope, but I don't know, I don't actually have a sample. I just have the data that here's its atomic number, here's its name, here's its half-life. In other words, would it make sense to be able to create a non-sample, just the idea, without an actual mass? Right? Does that make sense? Maybe, yeah. So instead of calling it sample, though, I'll call it my favorite isotope or whatever, right? But am I able to do that with the constructor that I just created, the two constructors that I just defined? Nope. So let's go over here and define it. Not the student, but in the constructor. So type, or what should I do? What was the trick that we used last time? Source, generate, constructor using fields, and I'm going to select all the fields except for mass. Right? And then let's go ahead and generate this. And of course, you can specify what this constructor is, the difference between these two constructors or whatever. And this one will set all of those values except for mass. If you want to set your own mass, this.mass is equal to -1 as a flag value. You can't have a negative mass. Or if you just wanted to let it, be the default value, the default value of 0, or just leave it omitted entirely. Right? Now this will assign a default value of 0. So you still have technically a sample. It's just a sample that is nothing, right? It's an empty bag. Okay. That solves my problem over here. Right? Now I've got my favorite sample, or I've got my favorite isotope over here. But maybe I do want another sample, right? I have a sample A and sample B as before, but with 5 kilograms instead. Code repetition, the DRY principle. What is the DRY principle? Don't repeat yourself. I repeated the first 4 things here, right? Is there a better way that I wouldn't have to do that? I want a sample, I've got a sample of strontium-90 isotope that is 10 kilograms. I want a brand new sample that is only 5 kilograms. So in other words, the first 4 things are going to be the same, but then the last one is different. Is there an easier way of doing this? Let's go over here to the isotope class, and let's create another constructor. Public isotope. And this one I'm not going to be able to auto-generate. I want to make a copy of a given isotope. Right? ... So these are just notes here. This is not good documentation here at all. Suggestions on how to do that. Well, if I need a copy of that isotope over there, then what do I have? What do I have in my hand? I have an isotope. That, right? And I'll actually literally call it that. Why that? Well, because I'm inside the isotope class, right? I am me. I am this, right? There's another isotope over there. What do I call that? Well, that, right? Now, that's not a really great variable name. In fact, that's a string. You can go ahead and call it that. And first, now I will, because I want to show you another trick here. But given that other isotope and this isotope, now what I want to do is I want to copy the values in that isotope over to this new isotope. So what do? This dot atomic number is equal to that dot atomic number. This dot name is equal to that dot name. Now you do have to be careful here, because what I'm doing is I'm making a deep copy. I have 2 distinct class instances. What about this, though? Is this a deep copy of a... Remember, name is a string. Is this a deep copy of a string? Are there 2 Strontium-90 strings sitting in my Java virtual machine in memory here right now? Nope. This is a... What's the opposite of a deep copy? A shallow copy. Does it matter, though? Nope, because strings are immutable. The problem with shallow copies, where you have 2 things referencing the same thing, is that if you change one, it's changed for the other, because they're pointing to the same thing. If you have 2 deep copies, though, changes to one don't affect the other. It doesn't matter in this case. Why? Because you can't even make changes. Right? So go ahead, make a shallow copy of a string. It doesn't matter. Right? That's Java. Right? That's because of string immutability. This dot symbol is equal to that dot symbol. Also a string that we can do a shallow copy of. This dot half-life is equal to that dot half-life. Right? What about that mass? Should I copy over that mass? If I did, then it would be a completely different copy. This dot mass is equal to that dot mass. Right? But is that how you want to call it over here? Let's come over here and say that I want to give you the same isotope of sample A. It'll still have 10 kilograms. Well, okay, I can go ahead and change it. Sample B dot mass. I'll go ahead and change that to 5 kilograms and immediately overwrite it. Sound like a good idea to have 2 pieces of code like this? No. Let's incorporate it over here. Right? So if you want the copy of that isotope, but just the 4 pieces of data, and you want a different piece of data for this 5th one, go ahead, do it. Double mass. There's no rules as to saying how, well, there are rules, but I'll talk about it in a second. But there are no rules that says you can't do something, and if you, there are guidelines that say maybe you shouldn't do something, but that's perfectly fine in this case. I want a copy of that isotope with the new mass. So this mass is not equal to that mass anymore. It's equal to the given mass of this thing over here. Okay. So this is called a copy constructor. This is not a pure copy constructor, but a copy constructor that makes a copy of the given isotope, but with the sample having the given mass. There we go. And that way, if I've got this, my favorite isotope, where I didn't specify a mass, I can create a sample with 10 kilograms. I can create a sample with 5 kilograms. I can create a sample with 8 kilograms, right? And I don't have to worry about the same 4 pieces of data over and over and over and over again. Right? This is called a copy constructor. If I had just had this, with like the single isotope, then it would be like a pure copy constructor. But this one is a little bit different. It's a copy constructor, but it's also changing something in it. Okay? Okay. Good. Now, let's rethink the variable name that, right? Let's name it something else. I don't know, is it strontium? Is it polonium? Is it plutonium, right? I have no idea. We'll just go ahead and keep it general and reference, let's see, where is it? Where's refactor? There we go. Rename, and I'm just going to call it isotope, right? This is actually quite common to have a generic instance of a class with the same name, but this is where naming conventions become important. Isotope, it'll be okay. But are you going to be able to understand the differences between those two things right away? Nope. But if you are following a consistent convention that all types are upper camel cased and all variable names are lower camel cased, then this is pretty clear, right? I mean, again, you could rename it a capital I isotope if you really wanted to. Refactor this, rename it isotope, right? And syntactically, it's perfectly fine everywhere. Right? Oops, I just undid it. Wait, what was the error message? It was actually letting me do it, right? Rename isotope. All right, there, okay. I'm glad that I shouldn't have gotten rid of that immediately. It's telling me, are you really sure you want to do this? This is not a very good idea to name a variable with upper camel casing. They should start with a lowercase letter, right? Oh, cool, okay. Yeah, I agree. All right, we'll go ahead and keep it that way by doing undo. Right. But I showed you a trick there, and I think I've showed you that trick before, but what was it? Highlight a variable, refactor, rename, and it changes all references to it that are within the scope. Cool. Questions so far? Okay, let's come back over here and let's use this copy constructor now to get 5 kilograms of mass or something like that. Now let's stare really hard at line 27. Is that a good idea to allow somebody to do that? Right? You created it with 5 kilograms, and maybe it does decay. And ultimately, later on, you'll go from 5 kilograms. After 30 years, you'll go down to 2.5 kilograms or something like that. Right? And we do want that functionality, but let's hold off on that for a second. Should I just be willy-nilly allowed to set the mass to whatever I want? No, that doesn't sound good to me. All right? So let's go back over here to what encapsulation is. Let's see. One of those aspects is protecting that data. If there are values, for example, negative mass, that you want to protect against, that there will never ever be an instance of this class with a negative mass, then you can protect it by ensuring by following good encapsulation. First of all, let's go back to the class and let's redesign this a little bit. As it is, everything right now is open to the public. It's actually package protected because I didn't put any keywords here. But you can go ahead and make something public, right? And we do that all the time with methods. If you've got a method, for example, a public constructor, then you want people to be able to invoke that method, to call that method. If you've got a method like main, and if it ain't public, then it ain't runnable, right? If you've got a method like square root, you want to make that public because you want people to be able to compute the square root function. Likewise, though, are you just going to let anybody do whatever they want with the mass of your samples? No. So instead of making it public, let's make it private. Now let's come back over here and see that on line 27, that's no longer possible. We've protected the data, okay? But maybe we do want to allow somebody to change it. We just want them to prevent them from changing it to something that's negative. That's okay. We can add that functionality down here through something called a setter. So this will be a public void because it's not going to return anything, and we'll call it set mass. Right? And it's a double, so mass, or I'll call it new mass. Right? There we go. This dot mass is equal to new mass. There we go. And over here, instead of setting it equal to directly, what I can do is I can set it equal to sample b dot set mass to that -5. Right? So I've created a framework in which now it is possible to prevent somebody from doing this. Now, syntactically, it's still fine. How do I do it over here? How do I take care of that issue over here, though? I can use some defensive programming. If the new mass is less than 0, what can I do? Reject it. Right? So if you give me some bad data, what would you do? You would what? Yeah, throw it back at them. Like, no way am I accepting this -5 mass. You throw what? A new runtime exception. Mass cannot be negative. There we go. Otherwise, we'll go ahead and set it to whatever you set it for. So let's come over here to the demo and see this in action now. If somebody tries to set it to a negative value, then we'll throw it back at them. You can't do that. The only way that it was possible to check for this is if you went into the class and established some framework by which somebody can change the data, but that we check for invalid values. We could say, somebody makes up their own chemical element, unellium, right? And we could reject that because we would look it up in a table of established scientific elements and say, nope, that ain't one of them, and throw it back as an error, right? Now this is the way. This is only possible with the protection of data, with these keywords public and private, and also protected, and the lack of a keyword. We'll go over that again later. But you don't have this in, say, C. In C, if you just have the first part of encapsulation where you're grouping pieces of data together. There's nothing to prevent somebody from resetting that piece of data to some invalid value, right? There is no protection of the data, and that's why in C we say that there's weak encapsulation. It only provides the grouping of that function of data. The protection of data comes by using these keywords. I like that so much that I'm going to do it on all of them. I'll make everything private. There we go. And now nobody can change these at all, right? Is somebody able to change the atomic number at all from outside the class if I don't create a setter? Sample b dot set mass is the only thing I can see. Dot name is equal to unellium. There we go. Can you do that? No. Why? Because it is private now. Right? You can go ahead and create a setter if you want. And by the way, I wouldn't type it out if I were you. I would go up to source, generate getters and setters, and then you can select all the setters. Right? It sees that I already have one for the mass, so it only generate the others, and there you go. Then you can go in and change your logic to say that, well, half-life can't be negative either if you really wanted to, or something like that. I'm actually going to get rid of all of them because I like immutability. In fact, I'll go ahead and get rid of this one as well. Immutability is a very good thing. VGT, right? A very good thing. Why is it a very good thing? Everything in Java is built into Java is generally immutable. Strings are immutable. Big D and big I integers and doubles, those are immutable. They can't, once created, they can't be changed. Because once you create them, you can't change them. That means that you have thread safety automatically. If two threads are working on the same piece of data and one of them is able to change it, that can pull the rug out from the other thread, the other part of the program. Whereas if you have immutability, that once created, you cannot change the values in that directly. You cannot change the values in that class. That's a very good thing, right? In fact, you can go a step further, right? And you can make all of these things private final. Right? So what is the final keyword in this context? Final is so if you were coming from a C background and I type something like const int x is equal to 10, and this will work in Java, except that it's going to warn me about the const keyword. What does this do in C? Can't change it. Why? Because it's const. Const is short for constant, right? You can do the same thing in Java. Let's go with final double pi equals 3.14159, right? There we go. Why would you want to do that? You don't want somebody changing your value of pi. And consequently, in the math library, that's exactly what it looks like. Math.pi, or let me go down here so I can actually type it. Math.pi is equal to 3. Can I do that? No, because it is listed as final. Right? So finals create a variable that cannot be changed. So if you want a completely immutable object, the atomic number, name, symbol, half-life, and mass, if you make them all final, then it is impossible to change them anymore. Right? That means that, there's no problem there, but let's see. There's no problem here either. This one, it's complaining why. Oh, the blank field might not have been initialized. Okay, fine. This dot mass is equal to 0. 0.0. There we go. Because I made mass final, right, then it's complaining about everything that's final has to actually explicitly be set. So to solve that problem, I'm simply going to get rid of that constructor. I really wasn't using it anyway. It was just for demonstration purposes. And down here, I'm going to think about this a little bit more. Right? What about the mass? I do want to model the decay of a radioactive element, right? So maybe I have an argument here for making the mass non-final. Right? It is not a constant. The atomic number doesn't change. The name of the element doesn't change. Right? The half-life doesn't change unless the rules of the universe start breaking down for some reason. But the mass can change because it can decay. It can go from 10 kilograms, and after 30 years, you only have 5 kilograms. So there is a design argument for making it non-final. The rest of them, though, private final, that's probably going to be the default that you want for pretty much anything, unless you have a, again, very good reason for doing otherwise. VGR, right? Okay. All right, let's come back over here, and we'll see that I can't set the mass anymore. I can't set the name, of course, etc. Okay. All right, that gets me through the protection of data. You can protect it through setters and control what it can be set to, or you can protect it by making it final, and then nobody can change it whatsoever throughout the entire lifetime of that object. Right? Okay. Questions so far? All right, well, I do want to say print it out, right? Let's go ahead and run this. And I do want to know about my isotope samples, right? And this is not telling me anything about them, right? This is the default behavior of the toString method that we've seen before. It just simply prints out the fully qualified path, that is the package, along with the class name, and then this mysterious value here that represents the Java virtual machine memory address. So again, I want a way to print this stuff out. So instead of printing out this first sample here, let's go ahead and say system.out.println. I'm going to go ahead and say sample a dot name, right? And then sample a dot, and then I'll print on another line. It's a symbol, right? Dot dot dot. And I'm already getting myself into trouble here. Why? Because I decided to protect my data. If it is private, nobody can change it, but also nobody can see it. Right? This is pretty innocuous. I'm not trying to set it. I'm not trying to change this object. I'm simply trying to pull out the data so that I can actually print it so that somebody can read it, right? That's where a getter comes in. So what's the opposite of setting? Getting, right? And so I can do that down here. Let's go ahead and jump down here and say, I want to get the name. So public string get name and return this dot name. And now over here, instead of accessing that thing immediately, I can go ahead and say dot get name. And that'll work. Let's go ahead and get rid of that for a second. Strong team 90. Right? Now I actually have access to my stuff. I can't reset it, right, because I am controlling access through getters and setters. But let's go ahead and do the rest of them. Type, or what? Source, generate getters and setters, select all the getters this time, and go ahead and generate them. there's no problem with allowing somebody or giving somebody the value of those fields right there. Okay, nobody can reset them. Just because I give you a copy of the half-life doesn't mean that you can change the original half-life. Right? I'm returning this by value, copying the value stored in that variable and giving you the copy of that value. Or in this case, I am actually giving you the string, but you can't change it, right? I have a guarantee on that because of immutability, a very good thing. Right? Okay. Then we can come back over here and do the rest of them. Dot get symbol, right? Dot, the rest of them. Except I wanted it formatted, right? Let's format this a little bit better. So system.out.printf, right? And the format that I want is the name, which is %s because it's a string. And then in parentheses, I'll put in the symbol. What did we do last time, right? We did something that looks like this. In fact, I'm just going to steal this, right? There we go. Come back over here and print this out. I can't use get name anymore. I have to use get name. I can't use atomic number. I have to go sample a dot get atomic number. And finally, symbol is going to be sample a dot get symbol. Right? There we go. So copy, paste for sample B, sample B, sample B. Right? Copy, paste for my other isotope. Copy, paste, copy, paste, copy, paste. Nope. For the same reason that you write functions, right? If you have a piece of code that you use over and over and over again, that's screaming out to you, put that into a function. If I've got the same piece of code here, it's screaming out to me to put it into a toString method over here in the isotope class. Right? I'm going to go ahead and go initially up to source, generate toString. And unfortunately, the default value of this is just going to take every single field and concatenate them all together in one big lump. Right? It's not very readable. I do want it to look something like this over here. Right? So if I replace it, what would it look like? This dot name, this dot atomic number, and this dot symbol. Right? Except that we're expected to return that as a string and not print it to the standard output. Right? This is the difference between, say, if you're coming from a C background, printf and printing to a string. Do you remember what the function you use to print to a string? Sprintf, right? Self-explanatory. S. What does the S stand for? Print to a string, right? I don't have the same thing here, sprintf. Instead, what I have is string dot, and then it's not even printf anymore, unfortunately. It's format. There we go. That formats a string that can then be returned. Nice little trick there. And now I don't have to copy, paste, copy, paste, copy, paste every single time. All I need to do is print out the actual object itself. Before, where it was printing out this fully qualified path name and then the Java virtual machine memory address, now it's got different behavior. Arguably, we can go back and clean this up a bit. For example, I don't want to force you to go to the next line if you don't want to. Also, it's the name, it's the atomic number, symbol, and I'm ignoring the half-life and the mass. Should that be part of the toString method? If you want it, yeah. If you don't want it, then no. Right? That's a design decision that's left up to you, basically. So do we want to put it in there or not? We could. More mass here. All right. So %f. What is the symbol for half-life? Chemist or physicist? Like if I say 28.3 years or 28.9 years half-life, is it half-life? Half-life? Is there any symbol for it? Any established symbol? All right, whatever. All right, years, and then finally, and what mass %f kilograms, of course, because we want to put our unit label there too, right? And so this will be this dot half-life, this dot mass. Okay, let's come back over here and rerun this. Go ahead and get rid of all the output. There we go. So they all have the same half-life, same half-life, same half-life, except for this third one, my favorite isotope. What was the default value of mass? 0. So you could put in a conditional that if it's 0, then you don't include this in your formatting, right? And you just say that, well, it's just a generic isotope. You can get as fancy with your output if you want. You can make some ASCII art if you want. You can do a lot of things here. Yeah. Say what again? Do you mean here?
Yeah.
Like, what do you mean?
You just type T 1/2 and then what?
Oh, yeah. I mean, if you want to abbreviate it or something like that, years or.
That's the actual symbol for half-lives.
Oh, what is it? T 1/2? I can't do that, though, can I? In ASCII text? Time half-life? THL? That might be something else. I don't know. Anyway, look up your chemistry book and tell me what it, and you know, decide what works best, right? Okay, that's good enough for now. Right. So that goes into the third aspect of encapsulation. You're grouping multiple pieces of data together. You also encapsulate methods within that class that act on that data. Formatting it for the purposes of printing it out or putting it into a file, that sounds like functionality to me. It's kind of, you know, trivial functionality, but it's still functionality. Where does it belong? It belongs in the class on which the data it acts on. Figure out those prepositions yourself. Does this functionality belong outside the class? Probably not, because we were cutting, pasting, cutting, pasting, cutting, pasting. Right? So anything that acts on that data, anything that acts on the atomic number or the mass or whatever, that belongs in the class. If you locate it outside the class, you are breaking encapsulation. Right? So, grouping of pieces of data, grouping of the functionality that acts on that data, and protecting that data from the outside world. Right? Let's have a piece of non-trivial functionality to this class here. Remember in the original demo, what did we do? We called this function called getMass. That given an initial mass, given the number of years that have passed so far, and given the half-life, it used this, where is it? It used this, well, it's right here, I guess. It used this formula to determine how much mass was left. So let's design that and include that as functionality here in our class. All right, it's going to be public, right? And it might return something, I don't know yet. And there should be some name for this function, right? So those are just placeholders. The name comes after you decide what it does. So when you're designing functions like this, what you should do is you should start with the documentation. What is this function going to do? If I start out with a certain amount of radioactive isotope, 10 kilograms of strontium-90, and if I wait a certain amount of years, right, not necessarily 28.9 years, but some years, like 1 year or 2 years or 3.5 years, then it's decayed at that point, right? It's decayed some over that time period. So this method decays, I don't even need to say this method, that's redundant, decays this isotope by the given number of years, right? ... Right? So you've got an isotope, and I'm saying 5 years have passed, right? That's going to change this isotope. It's no longer 10 kilograms. It's how many kilograms? Well, for that, we have to go back to our equations over here, right? So let's design it with this idea in mind, that you've got a piece of isotope of 10 kilograms, and you change it so that 5 years has passed. How many kilograms are left? Right? So what's the return type going to be? I'm the isotope. You're the outside code. You told me that I just decayed by 5 years. Do I need to give you anything back? No. If you want the mass after those 5 years, guess what? You can go ahead and get my mass after that, right? So am I going to return anything? Probably not. Right? I could, right? We could design this. So it decays this isotope by the given number of years and returns the amount in kilograms of the mass that was decayed. I could do that. In which case, what would the return value here be now? Double. Right? So you could do this one of two ways. Let's go ahead and keep that to do, consider a return value, maybe. Right? So keep that in my mind. Otherwise, for now, let's just go ahead and make it void. What should the name of this function be now? Decay? I like that. Why? Variables should be nouns because they are things. People, places, things. Functions, methods do things. What are words that do things? They're verbs, right? So decay. You will decay by a certain number of years, right? So int years. 1 year, 2 year, 3 years. Does that sound versatile? All right, let's make it a double, right? And also, to do, reconsider the input type, right? Years is not well defined. Why is years not well defined? How many days are there in this year? 365, right? How many days are there 2 years from now? 366, right? So years is not a well-defined concept, right? If I said 1 o'clock at noon, or 1 o'clock at noon, if I said 1 o'clock p.m., right? Is that well-defined? It's not even well-defined here, right? Are you on daylight savings time or not? CDT or CST, right? 1 o'clock p.m., you know, that's relative. Right? So if I just had a string that said 1 o'clock without any qualifications, that's really ill-defined. If you have to have launch a process like a database backup or something like that, and you just say 1 o'clock, what? Right? When does it actually occur? Okay. So it's relative. If it's relative, if it's not well defined, then then maybe there's a better solution. And that's why I put it in a to-do here. There is a better solution, but we're not going to get to it yet. Okay. Okay, so now I've decided that I'm going to implement this function by taking my mass, which say is 10 kilograms, and you told me that so many years have passed. And I'm going to say, okay, well, my new mass is this mass after decay. For that, I'm going to go ahead and go back over here and steal all of this stuff. Okay? All right, there. Mass remaining will be this dot mass times and then I need the C. What was the C? I'll put that up over here. Does anybody need access to that C? People need access to pi. People need access to 2.17E, 2.71, whatever it is, right? Does anybody need access to C? Nope. If it's internal, make it private. And, in fact, make it final so that you can't change it. Because that ain't going to change. If you want to, you can document it. This is the base exponent of the half-life decay, which I think just comes out to 0.5. So, but if you make it look like this, it make it look really fancy. Wow, there's a lot of mathematics going on over there, right? It's just 0.5. Okay, so there's my remaining mass. This dot mass is equal to remaining. Or I could have just said this dot mass is equal to this, right? And then I wouldn't have had to have that local variable there at all. Which one is better? 2 lines of code and 1 extra local variable, or just 1 line of code and no extra variable? Which one? Second one? All right. Oh, yes, thank you. So hold on to that question here in a second. So why is this better? All right, so when we talk about technical writing next week, I'll probably quote The Office. Why use many words when few words do? right? Shorter code is generally better code unless it's so short, so too terse that you don't understand what's going on. Right? There's no need to create another local variable and set it if you're just going to immediately take its value and put it somewhere else and then forget about it. This is definitely better. Right? Now, there was a question about half-life here. And yes, this half-life, if I click on it, it does take me to this half-life up here. That's because we had a problem when we did it in this constructor last time on Tuesday, because without qualification, there are two atomic number variables in scope here. This atomic number and the parameter atomic number. And when you do something like this, it has no effect because x is equal to x. The this keyword was absolutely necessary in this context. Down here, it's, or where am I? Where was it? There we go. Down here, it's not absolutely necessary because do you see two half-life variables, two variables named half-life in this context? No. So it's not absolutely necessary, but you should, right? It's best practice to do so. Even if you don't need to use the this keyword, you should still get in the habit of doing so. Because if you don't see the this keyword, you automatically think, well, wait a second, that must be some other variable, or that must be a global variable, or it's not possible in Java, but or that must be something other than the class's variable. So always get in the habit of using the this keyword. Now let's come back up here and spell consider correctly. Right? And let's take care of this to-do. Should we have a return value maybe? Right? How much did it decay after that many years? Which one would be more versatile? Which one would be more useful, maybe? Decay yourself by 5 years and give me how much mass you decayed by. Right? Versus decay yourself by 5 years, and I'll go ahead and get your new mass, and I'll go ahead and make the computations of what the old mass was minus the new mass to understand how much mass you actually decayed by. Right? Which one of those is a little bit more versatile or useful? I like it. So we will return how much it decayed by. Here's and returns how much mass the isotope decayed by. Okay. So I took care of that to do. I just need to. Oh, I didn't take care of it yet, did I? Right. So now you have an argument for establishing another local variable, right? So double remain is equal to this. This dot or double decayed mass is equal to the original mass minus the remain. This dot mass is equal to the remain. And then finally you can return the decayed mass. Now you might get clever and think that you can take away 2 lines of those codes and you would be right, but there is an argument for not making it shorter, right? This is absolutely clear. Do this thing, then this thing, then this thing, then this thing, right? By making variables that have descriptive names, I can follow along and understand exactly what's going on there. Whereas if you were clever and, I can eliminate that variable by doing this clever math over here, this clever algebra, right? Then you might lose the forest for the trees. If you didn't have a decayed mass variable and you just return some expression, right? Would it be entirely clear what it would be doing? Not unless you read the documentation. And even then, okay, well that tells me what the intent is. Did they actually do it down here? Because I need to fix a bug. It's not working, right? And there might be a discrepancy between the actual documentation and what the code actually does. So it's still necessary to make sure that your code is readable. Okay? All right, let's go ahead and use this now. So my sample A dot decay by how many years? 5? Okay. We'll go, well, let's have 5.25 so that, oh no, let's go ahead and go with 5 years, right? Decay, right? Did I capture how much it decayed by? Nope. Because I didn't want to, but I still had the option of doing it, right? Just because I'm ignoring it doesn't mean that that was a bad design over here, right? You can do that all the time. You can have a method that changes the object. It makes it mutable, of course. And then you can ignore the return value if you really want to. Right? But let's go ahead and capture it. Decay mass. equals this. And then I can print that out, right? What would that loop look like now over here? So I had a loop for going until it got to the half of the original mass here, right? I would have decay, 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 and then just print it out. All of this stuff here, getting the mass by calling this method up here and all that stuff, it's just 2 lines of code now. It's 2 lines of code anyway, but it's actually object-oriented style. That I'm not locating functionality outside the class. Again, let's go back over here. Encapsulation means that you have the functionality that acts or operates on that data inside the class. The idea over here was I was ripping the data out, throwing it off to another function that was located completely outside of the class in order to do my work, breaking encapsulation. But now, that functionality is in the class that it makes sense for. Would you take a square root function and throw it into the string class? No, right? That's basic organization. Right? So would you take something that did isotope calculations and throw it into a loan application class? No, right? You locate stuff where it belongs, where with the data that it acts on. Okay. What about that input type? It's not very well defined, is it? Right? I called it years, but even years is undefined. Well, not well defined because some years are different. Right? For this, let's go ahead and go back over here to the student class, and let's remind ourselves of a classic example that I always use in Computer Science 1 of, okay, now I want to know how old this student is. So in other words, I want to know what their birth date is. So how could I redesign this class to allow a birthday? How do we usually do it? What is today? It's a date, right? What is today's date? February 3rd, 2022. That sounds like 3 pieces of data to me, right? So private int day, private int month, right? Private int year. Why did I make them all ints? Well, a day can be 1 through 31, although, depending on the month, some of those days are invalid. A month can be 1 through 12, okay? And a year can be anything, right? You go back in time. Here, BC would be negative, right? And assuming that we can keep existing until the heat death of the universe, then it won't matter how big our years are, right? Although we couldn't go past the year 2.147 billion, could we? Right? All right, that's one way. Except that 3 pieces of data, what should that be yelling out to you? Put it in another class. Right? Maybe a date class. Right? However, should you reinvent the wheel? Right? So, don't repeat yourself. Don't repeat somebody else either. Is there something that we can use already? Let me cancel this. And yes, private date, or local date, I think it is. Local date, right? Birthday. Birth date, I'll say. Right? Local date is built into the Java time library. Right? And why is it called local date? What is today? February 3rd, 2022. Is that the same day over the entire planet? Nope. Cross that international date line and it is a different day, right? So what does local date mean? Well, it's local to whatever you're running the program at the time. There is an idea of a universal time, right? All you have to do is select a position on the planet, and that's the universal time. It's called Greenwich Mean Time, right? GMT. And then anything is an offset from that. You know, you could be behind GMT, you could be ahead of GMT, you could be on daylight savings time. Not every country does daylight savings time. In fact, not every state does daylight savings time, right? Arizonans? Yes, no? Okay, I don't know if they still do it or they still don't do it or not. But in any case, it's not a universal, and that's why it's called local date. Right? Well, let's come. I'm not going to show you the functionality here just yet, unless you want to see it. But let's come back over here and rethink our years. All right? Is there something in the Java datetime class or datetime library that allows us to define a duration D? What is a duration? Well, a duration is a time, a chunk of elapsed time. A duration could be like 10 minutes or 100 years or 5 seconds. And you can go back in time. So -5 seconds if you want a duration that goes back in time, I believe. Maybe not. Maybe if you take a period between two things and you're reversed, it's still 5 seconds. It's just, you know, it's still going to be 5 seconds. It's just that your reference time is going backwards in time or something. There's also a period. Right? A period is actually a duration between two specific date times. So today at 1 o'clock until tomorrow at midnight. Right? That's a duration, but with two specified dates. A generic duration, like I had before, is just the concept of a duration. 5 seconds, 10 years, 3 weeks. Right? So I'm going to go ahead and use duration instead. Why? Because it's more universal. What is a year now? 365.25, I believe. Actually, it doesn't even have a support for a year. Instead, you have to think of things in terms of atomic units, nanoseconds or milliseconds or something like that that are universal. And then you get into time relativity and it's not universal anymore. But don't worry about that stuff. Right? More physics, right? There we go. And it's not going to be years anymore. To get years out of duration, what I need to do is d dot get seconds, no, get days, hours. I'll go ahead and get days. And there are, divide that by 365.25 to get years. Oops, 365.25 to get years. Right? Now, in this case, I did have to extract the number of days, divide by 365 to get the actual years, but that makes the interface, how the outside world interfaces with my class, a lot more universal. Because instead of just giving me a generic number, right, it has an actual duration. A duration can be years, a duration can be seconds, a duration can be anything. It depends on you, how you built it. Before, what I had here was double, I'll just call it X here. Do you know what units are in X? Nope. The only way that we knew what units were in X was by calling it what it was, years, and making some documentation on it. Well, what if somebody mistook this and just said X? Okay, what is X? Oh, it decayed only for 5 seconds, or it decayed for 5 weeks, 5 years. Right? That is way less versatile, or way less specific, or far more brittle, I should say, than using a class like, say, duration. Right? Now, duration, you built the duration, you know what it is. Right? Let's do it out here. Duration D is equal to duration dot, and here's it doesn't have a constructor. Instead, what you have to do is go of, and then specify the amount, days, and then 365.25. I don't even think you can do this. I think it has to be a round number. Yeah. So we'll do, 365.25 times 5, and then I will make that into a long. There we go. So we're going to be off a little bit, but so be it. D. There. All right. Now, I'm the one that built the duration, so I know what the units are supposed to be. In fact, the units are now universal. There are other ways of doing this. Duration d2 dot of, d2 equals duration dot of. You can actually specify a temporal unit here. So the amount would be, say, 5 years, and then what was the class called? Temporal unit. Temporal unit dot, is there years? I need to import that, I guess. Temporal unit, come on, dot years. I thought that this would work, but there we go, import. And it's not years, what's available to me, dot, oh, okay, units, nope. All right, I forget how to do it. I'll have to look that up and let you know. All right, but there are ways of doing it. Okay. this is looking pretty good so far, right? I mean, it's kind of messy because I've got some dead code here that I'm going to leave in here because I'm going to actually post it, and you'll probably want to see it. But if I were to actually turn this in for an assignment, I would definitely get rid of that dead code. I would get rid of that dead code. I would get rid of that to-do. In fact, I'll do that right now. All right? Get rid of that to-do. What about this to-do? Should we have this? Yes. We made it mutable. It can be changed so that we can change it through that decay method. And then the last thing that you need to do, or maybe it was the first thing that you needed to do, is document the entire class. Right? So this models and radioactive isotope. C, and then what was that Wikipedia page that we brought up? There we go. More information can be found here. Good. Okay, format, please. Thank you. There we go. More information can be found here. What else? I documented the decay, except that it's not correct anymore because I was changing it all over the place. So let's go ahead and do this. There we go. And there. There we go. All right. Constructors don't need to be documented. The actual member variables don't need to be documented. Getters and setters do not have to be documented. The toString method does not have to be documented. Those are all trivial methods. Okay. Now, you might take a job at some point where you're doing Java and they do have a style guide that says all of these things have to and should be documented. In which case, okay, fine. But then you're getting paid by paid a handsome salary for writing cruddy documentation. So, you know, count yourself lucky. And yes, it's grunt work, but at least you're getting paid for it then, right? Okay. Questions so far? Otherwise, I think that's a pretty good design of our class, and we've used it. And now we can take that loop and rewrite it. So for this, I'm just going to go, since it's strong TM, I'll just say 30 years. Let's go with 30 years. And there's sample A, so sample A dot decay. And I need a duration here. So duration, I only actually need one duration, and it'll be 1 year. There we go. Here's a better way of writing that. One, it's still good. Here, I'll write it as year. 365. There we go. Sorry about that. Right. Decay by that year. Right. And then print it out. Print ln sample A. And we'll see that it all comes together with two simple lines of code. Decay yourself and print, and I want to print you. Decay yourself, print you. Decay yourself, print you. Right? And there we go. And it went for 30 years, so it's going to go even lower than it was before. But 8. Oh, sorry. Those are the print statements above. Otherwise, it starts out at 8, 4, ... all the way down to after 30 years. Right? And maybe you want to format that a little bit differently. Okay. No questions on that at all? All right. Then let's try to enumerate what we just did. So objects. I guess I've got it up there, but so formally, an object is a general entity characterized by, and I'm just going to cut and paste these. 1, identity. There's some aspect of the object that distinguishes it from all other instances. In the case of Java, that's where it lives in memory. So if I've got a sample A, sample B, sample C, those may have the same values, strong TM90, strong TM90, strong TM90, but they all live in different spots in memory because I called a constructor on each individual one. They might have a sample that it's 10 kilograms and 10 kilograms over here, exactly the same, but they still have identity because they live in different parts of memory. Second is state. And the state is a collection of properties, elements, attributes, data fields, or what we usually call them are member variables that represent the state of the object. So for example, over here in the isotope, these 5 pieces of data represent the state of the object. C is not a state of the object. It's a state of the class because we made it into a static variable. It doesn't change, right? These things can be changed from one instance to the next. Finally, behavior. Functionality of the object, or what it does, or what services it provides. If I had an object, if I had a class that was responsible for logging, right, and it logged to a database, or I had another class that logged to an output file, right, then there would be some interface that I could interact with it and say, log this information to wherever you're logging to, right? And that's its behavior. That's the functionality. That's the interface that it provides. What does it do, right? And I need to send it a message for it to do so, right? So communication between objects is done via message sending, right? That you invoke a method on an object, and that object executes the code inside that method, That's nothing novel, right? You call the square root function exactly the same way, and you know that the square root function will execute some code that's contained within. But an object is different, because if you send it a signal to decay by a certain number of years, then it's not only executing its code, but it's also potentially changing its own state. Or it's looking at its state and saying, well, I've got 10 kilograms right now, so if I decayed that by 5 years, then I would have this much kilograms afterwards, right? It is using its state, and it is potentially modifying its state, right? So it's communication between these objects is done by message sending, right? Communication is facilitated by the object's interface, right? The public methods, and I will highlight that, public methods that are available. Facilitated, there we go. Right. So if you've got private methods, that's not part of the interface of the object. Over here, let me restore this. Right. And in fact, let me regenerate it, because I made so many changes. Generate a constructor, the default constructor, so deselect all, generate, there we go. Okay, it's still going to complain. Fine. Actually, here, I'll show you another trick. So I want default values for all of these things. What I could do is I could do a cut and paste here. Give me some sensible defaults. Atomic number. Is there an element of atomic number 0? Nope. So that's a nice flag value. Name. Unknown. Symbol, maybe null. Half-life, maybe 0, indicating that it's a stable element, 0.0. And mass, 0.0. An alternative would have been to make it a big D double, right? And then to make that null as well. I don't think anything will break in this case, but there you go. Now, if anybody tried to use that in an equation, like they took the mass and multiplied it by 5, null times 5 is going to be an exception thrown at you, right? So there's another way of doing it. Anyway, back to the task at hand here. If I want to set all 5 of these things, that's a lot of repeated code. This one and this one. How could I cut down, DRY, don't repeat yourself, how could I cut down on all these things? I could make sure that I call this constructor with these values, 0, unknown, null, 0, and null. Right? I want to call it isotope 0, unknown, null, and 0.0, and then null. I can't do that, though, because there really isn't a function. I would have to go new, and then that would be yet another function. Right? So how do I refer to a constructor in this object? Again, with the this keyword, right? And why are you complaining? All right, what is it? Atomic number, number, name, symbol, 0. Oh, and then this takes a little d double, so I'd have to change that to take a big D double. And unfortunately, that breaks this over here then. All right, why are you complaining? 10.0, there we go. All right. Got to be specific. But that's a way to reduce repeated code. You have a function, you have a constructor that invokes another constructor, and that constructor is determined by the types of variables that you give it, the number of variables and the types of variables that you give it. Okay. All right. Back over here. Again, the interface is the public methods that are available. I could have a constructor that does something like this. I could have a constructor that takes no arguments, but then I could make it private. And that constructor is no longer part of the interface because nobody can call that constructor at all. Right? What's the point of having a private method, right? That nobody can call? There might be some use cases. Right? There might be some, some internal initialization functions or something like that where you make it private. Right? It's just possible. Okay. Otherwise, anything that is a public method is part of the interface of the object. Right? Objects are constructed rather than just assigned. Right? And how did all that work? In Java, by default, a no argument constructor is provided. If you define your own constructor, it goes away. Right? You can always restore it by explicitly defining it. Right? And you can define as many constructors as you wish to make your objects more usable. Right? You have another way that you want to create something. Go ahead and build that for yourself. Design it for yourself and implement it. Right? Common patterns. You can have copy constructors that take another instance of the object and make a deep copy. Right? Partial copy constructors. Copy constructors that take an object and other values to make a partial copy of the object. Right? Those are going to be very, very useful patterns as you get into your project. You're going to want to design in your first phase that's due 2 weeks from this Friday, so well over 2 weeks. You're going to be designing your objects up front, and then you're going to, in the next phase, in the second phase, you will be using those objects, or maybe redesigning them a little bit and using inheritance once we've talked about it, but you will make them interact with each other. And if you've got, say, 50 shares of Google stock on one portfolio and 100 shares of Google stock on another portfolio, that sounds like the perfect use case for creating a copy constructor that I can create a copy of Google stock with 50 shares, put it over there, a copy of Google stock with 100 shares, and put it over there. Right? Just like I did with this isotope class. Create an isotope with a different mass, and you've got this copy constructor going on. All right, we'll go ahead and bring it back on Tuesday then. On Thursday next week, we will have a special guest. I'll still be here, of course, but from the Writing Center, and we'll start talking about your design document draft and how to go about doing it. Okay.